Welcome to the final video of this module. In this video, you'll be introduced to some of the core concepts of logic and some basic terminology that is related to the evaluation of arguments. Now, these particular concepts that we're going to discuss here are absolutely foundational to logic, so it's worth paying very, very close attention to this material and going over it more than once. If you don't understand this particular set of ideas, I would suggest to you that the rest of the quarter is going to be increasingly difficult as we start moving through the material. So let's start by simply introducing some very basic terminology, some language that we'll be using to talk about arguments and evaluating arguments over the entire quarter. And from there, what we'll do once this is finished is move on to actually look at the content of these ideas to figure out precisely what they mean and what they imply. So to begin, when we talk about deductive arguments, the basic terminology with evaluation we're going to use involves the idea of validity and soundness. And with induction, we find two different terms that basically mean the same thing. We'll talk about strength and cogency. And then finally, what we need to do is figure out what relationship these basic ideas have to a different set of concepts, the idea of a truth claim. So in terms of the location of this material in the book and really in the course, what we're talking about here is stuff from chapter 1, section 1.4. So once again, the basic concern of this material and the basic concern of these various terms, validity, soundness, cogency, and so on, all of these ultimately have to do with evaluating different types of arguments. But it's worth noting that what we're not talking about here, at least not yet, is the actual process or methods used to evaluate specific arguments. We're not actually going to be doing that yet. Instead, what we want to know is what fundamental conditions would have to be met in order to say that you have adequately evaluated any argument at all. So in the end, basically what we're asking for, looking for, the basic meta conditions necessary for argument evaluation as such. I think a very clear and basic expression of this idea can be found in your reading right up front in section 1.4. Hurley writes, "Every argument makes two basic claims, a claim that evidence or reasons exist, and a claim that the alleged evidence or reasons support something, or that something follows from the alleged evidence or reasons. The first is a factual claim, the second an inferential claim." So another way of thinking about this is that when we evaluate arguments, there are two fundamental questions that have to be addressed. And one of these basically is going to address the factual claim, and the other is going to address the inferential claim. So we can articulate these questions in the following ways. The first is, do the premises logically support the conclusion that's drawn? And the second is, are all the premises actually true? Now, what's really, really important here is that these two different questions or concerns are radically different from one another. They do not imply the same thing, and they do not ultimately entail one another. What this means is that an argument can fail in two different ways. On one side, you can have an argument that fails because the premises do not logically support the conclusion, and that's wholly independent of whether or not your premises are true. And on the other side, you can have an argument fail because your premises are simply false. They're not actually making realistic claims, even though potentially the argument itself is quite logically coherent. So what I want to do next is try to make sense of this distinction by giving you some very extreme examples that will hopefully clarify how an argument can fail on one side and yet not on the other at the same time. So let's take the following argument as an example. Now this example is quite extreme and it's obviously stupid, but that's pretty much the point. The goal here is to give you a very intuitive and clear understanding about the difference between these two different questions. So the argument says, because we know that water freezes at approximately 0 degrees Celsius, therefore it must be the case that dogs are mammals. Now the first thing to note about this argument is that all of the premises, well there's only one, but all the premises are actually true. It is true that water freezes at approximately 0 degrees Celsius. And notice even in this case that the conclusion itself is true. Dogs are in fact mammals. Why this argument fails, and what makes this such an absurdly stupid argument, has nothing to do with the factual status of the claims. Rather, the problem here is that the premise, even though it's true, doesn't in any possible or rational way support the conclusion that's drawn. That is, if I didn't know whether dogs were mammals or not, knowing that water freezes at approximately 0 degrees does nothing to help me sort that out. So technically speaking, the logical mistake here is that the premises do not in fact support the conclusion. So let's take a look at another example, and in this case it'll work the other way around. So this argument claims every person involved in this class is male because every person involved in this class is a student at Eastern Washington University, and Eastern only has male students. Now notice the conclusion here is that everyone in this class must be male. And our evidence, of course, are the two following claims: that every single person in the class is a student at Eastern, and Eastern only has male students. Now, the most obvious problem with this argument, of course, is that nothing in it is true. Right? Every single statement all the way through is essentially false. It is not the case that every person, of course, in this class is male. We have a number of female students in the class. It's also not the case that every person in this class is a student at Eastern, because I'm in the class and I'm not actually a student here. And we have ample proof that it is not the case that Eastern only has male students. So every single claim in this is in fact false, and that's what makes this a really bad argument. But notice that those two premises do in fact support that conclusion quite well. If you stop to think about it for a while, if it were true that every single person in the class was a student at Eastern, and it was also true that Eastern only had male students, that would give us really good, concrete, and serious evidence to think that everybody in the class would have to be male. So logically speaking, those premises do in fact support the conclusion. This argument fails not because of the reasoning. The inference is actually quite plausible. Why it fails is because the claims in there are simply false. And again, if you compare these two different arguments, what we see is arguments can fail quite radically in two very different ways. So before moving on, let me reiterate again that this is a very, very important basic concept for the class. So if you didn't quite get what happened with those two examples, or you don't really understand the difference between the truth claims in an argument and the logical coherence in the argument, you might go back and review that material. So for now, what we're going to do is move on to some terms and basically defining the terms we started this video out with: validity, soundness, and so on. So the first term we need to discuss here is the idea of soundness. A sound argument, technically defined, is an argument that is both valid and that has all true premises. Now, if you pay attention to these two different criteria that soundness would have to meet in order to become a sound argument, it turns out that these two different sides of the equation, validity on one side and all true premises on the other, are really just sorting out these two different questions we have. Validity is fundamentally concerned with the question, do the premises logically support the conclusion? And that is true independent of whether or not anything you've said is true. On the other side, the second question is asking simply, are the premises actually factual or true? So one way to think about the idea of validity in an argument is always going to be hypothetical. And what this means is we want to think about this by just basically assuming that if all the premises are true, would the conclusion actually be necessarily true? Because we're talking about deductive arguments, what we find is in a valid argument, if the premises are all true, then I will get a necessarily true conclusion. So keep in mind when we talk about validity that this is always hypothetical. In other words, what we do when we think about validity is we take any and all concern for the truth of our statements simply off the table for a little while. Now, in a sound argument, we care deeply about the truth of our claims. But with validity, validity is not interested in asking the question, is any of this stuff true? All we care about is the question, do the premises logically support the conclusion? And that is wholly independent of whether or not anything in the argument is actually true. So when we look at these two terms, soundness and validity, The first point that's worth making here is that these two terms exclusively refer to deductive reasoning alone. We'll have completely different terms when we talk about induction, even though the basic ideas are the same. So at any point in this course, when you hear the idea of soundness, you should be thinking about deductive reasoning, and the same is basically true for validity. If I say an argument is valid or invalid, I must technically only be talking about deductive arguments. Now, validity is often used in ordinary language to mean other things than this, but in logic it has a very specific meaning, and what it means, of course, is that it's a deductive argument where the premises support the conclusion. Now, notice then, that basically is the full definition of a valid argument. A valid argument is one that is deductive, and the premises logically support the conclusion. And this is so independent of whether or not the premises are actually true or the conclusion is true. So to say an argument is valid just means it's a deductive argument where the premises support the conclusion. And a sound argument, notice, is a sound argument that is both valid and that has true premises. And what you will find is that necessarily this will produce a true conclusion. So sound arguments will always have true conclusions. Another point about soundness that is worth making here is that, notice, a sound argument must have a true conclusion, no matter what. But merely having a true conclusion is not what makes an argument sound. A sound argument is going to be defined as one that is both valid and that has true premises. And as a result of meeting these two criteria, of being valid and having all your premises true, it will produce a true conclusion. But the mere fact that you have a true conclusion is not sufficient to say that any argument is actually sound. So what exactly is the relationship that exists between validity in an argument and the truth claims of an argument? Well, as we'll see, it turns out it's pretty much anything goes. To make this point, we can just start with an example. Look at this particular argument. All stars are objects made of cheese, and the moon is a star, therefore the moon is an object made of cheese. Now, very clearly it's a stupid argument, but if we look at the actual form here, what we're actually arguing is basically that all S's are C's, all M's are S's, and therefore all M's are C's. And for what it's worth, this is a valid argument. And if you stop and think about it, if it were true that every single star in existence was made of cheese, and it was also true that the moon was in fact a star, then it would follow necessarily that the moon has to be made of cheese, because the moon is a star and stars are made of cheese. So while this is a valid argument, the problem here has to do with simply truth claims. None of the claims are actually true, even though it's a valid argument. This is a very important point. And in fact, if you think about that particular form of reasoning, it's valid wholly independent of any of the contexts that we're talking about. Whether we're talking about stars, moons, and cheese, politicians, liars, and sinners, and so on, this form of reasoning is a valid form of reasoning. Because if it's true that M's are S's and S's are C's, then no matter what, M's would always have to be C's. Now, if we look at this particular form, we can start playing around with the truth values of our claims by plugging in different things for M, S, and C. So take, for example, the following argument. All Greeks are humans, all Athenians are Greeks, and therefore all Athenians are humans. Now notice the form of this argument has not changed from the original stars, cheese, and moon argument. But in this case, what we have are both of our premises are true, and it has a true conclusion. Notice it also has a valid form, which means this is a sound argument. The claim that all Greeks are humans and all Athenians are Greeks, therefore all Athenians are humans, is a sound argument because it's valid with true premises. Notice if we tweak this a bit, what we get is something like this. All cows are humans, all Athenians are cows, therefore all Athenians are humans. Well, notice in this case I have false premises and a true conclusion, but it's still a valid argument. Nothing's changed in terms of the order of our reasoning. Logically speaking, if we just assume the premises to be true, we have very good reason to accept the conclusion. Now notice in this case, it is no longer a sound argument because it has false premises, but the fact that it isn't sound is not sufficient to say it is invalid. Validity, remember, does not care about the truth of our particular claims. So let's push it one step further so that we make everything false. We get all cows are humans, all reptiles are cows, and all reptiles are humans. Notice in this case, everything's false. It has false premises, the conclusion drawn is false, but it does have a valid form still. Nothing has changed. It has the exact same form as the other arguments before it, and the result here is essentially that we don't have a sound argument, but we do have a valid argument. So again, the basic idea here that these examples are supposed to be showing is that in the end, the relationship between truth claims and validity is incredibly loose. It's pretty much anything goes, with one exception that we'll see in a moment here. Now, soundness is a different question. A sound argument must have true premises and a true conclusion, and it must be valid. But validity is a radically different concern. So remember, when we think about the idea of validity, we're only interested in the question, do the premises logically support the conclusion? And that is wholly independent of any concern for the truth of the statements. So for the most part, it seems that the relationship between the validity of an argument and the truth of the various claims of the argument is kind of anything goes. But as I just mentioned, there is one fundamental and very important exception. And so what we need to do is figure out precisely what that is. So while the relationship between truth and validity seems to be pretty much anything goes, in the end, we ultimately can't say that they are totally independent of one another, because there is one fundamental important exception. Any deductive argument where all of the premises in the argument are true, but nonetheless a false conclusion is drawn, must be an invalid argument. Now let me repeat this. If all the premises of a deductive argument are true, but we have a false conclusion, this must be an invalid argument. So basically, what we're looking for here in the exception to the rule is where all the premises are true and the conclusion is false. If you ever find a case where you know that all the premises in a deductive argument are true, but I end up with a false conclusion, this must be an invalid argument. We can actually use our little formula here about soundness and validity to actually prove logically that this must be the case. So the way to start here is by looking at the idea of soundness. A sound argument, remember, must have a true conclusion. Now, let me reiterate a point I've already made. The fact that you have a true conclusion is not what makes it sound. Sound arguments are arguments that are both valid and that have true premises. But as a result of meeting those two criteria, we must have a true conclusion. So if the argument's sound, then you must have a true conclusion. So notice, in any instance where I have true premises and a false conclusion, this logically means it can't be a sound argument, because sound arguments must have a true conclusion. If the argument has a false conclusion, we know it must not be sound. And of course, if it is unsound, then it cannot be both valid and have all true premises at the same time. Because if all of my premises are true, and it was a valid argument, I would get a sound argument, and a sound argument must have a true conclusion. So a false conclusion means it can't be sound, and the result is that it cannot be both valid and have true premises at the same time. One or both of these things must be a problem with the argument. Either it doesn't have all true premises, or it is not a valid argument. But of course, when we're looking at an argument where all the premises are true and I get a false conclusion, it's not going to be a problem with the premises. That side of the equation is fine. So it's not sound, but it does have true premises. And so the result, by basically rules of a disjunctive syllogism, what we find is that it must not be a valid argument. You cannot have a valid argument that has true premises and a false conclusion. So this chart is located in your textbook around page 44. It depends, frankly, on which edition you have, and there might be slightly different examples in the chart. But it is a very important chart, and it's worth paying really close attention to the information that it's giving you. Notice that this table here essentially gives us every possible relationship that could exist between the truth claims in an argument and the idea of validity. So notice if we go to the top line there, we see that we can have an argument that is valid where our premises are all true and the conclusion is true, but we can also have arguments that are invalid where the premises are true and the conclusion is true. If we drop to the very bottom, notice I can have arguments where every single statement in the argument is false, and that might be valid and it might be invalid. Now, the only time you get something sound is in the top left-hand corner, where essentially everything is true and it's valid. But notice the fact that everything is true is not enough to say that it is a valid argument, and the fact that everything is false in it is not a good reason to say that it's invalid. Now notice too, one last point about the chart, if you look at the second level down, or row down, what you find is true premises and a false conclusion cannot exist in the form of a valid argument. This is a very fundamental point, and believe it or not, when we get into modern symbolic logic, propositional logic, and natural deduction, this is going to be absolutely central to making sense of almost everything we do there. So pay very close attention to this fact. I would in fact encourage you to spend a little time just staring at this chart, making sure you understand precisely what it's telling you. And if you have questions about that, feel free to come talk to me about it. So far, everything we've looked at in this video has dealt with deductive arguments and the terminology we use to talk about deductive arguments, soundness and validity, and so on. But it's worth noting that we also have all of these same ideas repeating themselves with inductive reasoning as well. So it's worth taking a little bit of time to go through this to learn the terminology related to induction and to recognize that with evaluating an inductive argument, all the same stuff fundamentally applies. So when we evaluate inductive arguments, it turns out that there are two fundamental questions that must be addressed. One deals with factual claims and one deals with an inferential claim. And frankly, they're exactly the same two questions we saw with deduction. The first question is, do the premises logically support the conclusion? And notice this idea is exactly the same as we saw with the first. This has to do with logical coherency, not with the truth of your claims. The second question, of course, deals with the factual aspect of an argument. Are the premises actually true? So when we start talking about inductive arguments, we're going to end up using a different set of terms to explain these fundamental ideas that we've been talking about with deduction. The core idea here is identical to what we saw in deduction, but we use different terminology to distinguish between an inductive argument and a deductive argument. And it will turn out in the end that our concerns about inductive arguments, and in particular about the idea of strength, are going to be a bit different than what we would do with deduction. But that's not our concern in this class, so for now what we want to do is simply introduce this terminology and move on from there. So in an inductive argument, what we're looking for, the ideal endgame of an inductive argument, is simply cogency. An inductive argument can be cogent or uncogent. And what it means to say that an inductive argument is cogent is quite simply that it is both strong and it has true premises. Now notice the idea of strength here, strength and weakness, is what we're going to use to describe the basic idea of logical coherency in an inductive argument. Strength refers to our first question, do the premises support the conclusion? And the idea of having true premises refers to the second question, are the premises all true? So just like with validity and deduction, the idea of strength is also always a hypothetical. That is, if we simply start with the presumption that all the premises are true, the question that strength is attempting to answer is, would the conclusion follow from this? Would it be a highly probable conclusion to draw? Now keep in mind, just like with validity, when you talk about the strength of an argument, we are fundamentally not concerned with the truth of our propositions. And just like with deduction, an argument can fail on either side. I can have a strong argument where everything is false, and I can have a weak argument where everything is true. Now, in terms of the basic terminology we use with induction, the idea of cogency and strength and weakness, the first thing to note about this is that when you say cogent or strong, you are always talking about inductive arguments, or at least you should be. Deduction uses different terminology. The basic idea of cogency in deduction is soundness, and the basic idea of strength in deduction is validity. The core concepts are basically identical, but we have a different set of terms to describe induction versus deduction. Now, what it means to say an argument is strong is quite simply that it is an inductive argument, and the premises logically support the conclusion as drawn, and that is wholly independent of whether or not anything in the argument that is said is actually true. Again, strength is not concerned with the truth of the premises. Of course, cogency will be, but strength is not. Now, a cogent argument, just like with deduction, is definable simply as an inductive argument that is both strong and that has true premises. That is what makes a cogent argument cogent. As a result of this, you will get a conclusion that is very highly probably true. Now, again, just like with deduction, the fact that an inductive argument has a true conclusion does not make it cogent. What makes it cogent is that it is strong and it has true premises. The result of meeting those two criteria is that the conclusion is probably true. Now, when we talk about the strength of an argument, it turns out that the considerations here between deduction and induction are a bit different. So the first consideration here is this. Strength will always be determined by an assessment of the degree of support the premises offer to the conclusion drawn. One way to think about this is in simple contrast to the idea of validity in deduction. In a deductive argument that is valid or not valid, this is an all or nothing thing. Deduction is either valid or it's not, and there is no middle ground, there is no kind of gray area here. In induction, strength is always a matter of degree. That is, it's all gray area. You will never have something that is 100% strong or 100% weak. Instead, what you get is stronger and weaker arguments, and we have to assess them accordingly. To make sense of this point, it doesn't hurt to return to a very simple example, one that we saw in a previous video. So if you look at this argument, the snow in Spokane argument, it says it has snowed every single winter in Spokane for the last 100 years. Therefore, it's likely going to snow this coming winter as well. Now notice this argument, if you think about it, is reasonably strong. That's fairly compelling evidence that it's probably going to snow next winter. Now, is it a guarantee? Of course not. But it is nonetheless reasonable evidence, and it's probably strong enough to get you to actually change your behavior accordingly. Now let's compare it to this argument. It has snowed once in Phoenix in the last 100 years. Therefore, it will likely snow this coming winter as well. Now, in comparison to the first argument, this is incredibly weak as evidence for snow next winter in Phoenix. But of course, notice neither one of these is a guarantee of anything. It might well not snow in Spokane, and it might snow in Phoenix. We don't know. But in terms of evidence, it's very clear, or at least it should be, that the first argument is much stronger than the second one, which is much weaker. Neither one is 100%, but essentially what we get is a matter of degree. And if you think about these two examples, right, it has snowed 49 winters in Spokane out of the last 100 winters, or it snowed 51 winters in Spokane out of the last 100 winters. In some technical sense, the second one is a stronger argument than the first. Now, in the end, it's basically just flipping a coin, and the difference is utterly trivial. But really, there is more concrete evidence. It has a higher degree of support in the second argument than the first. So this is what I mean basically by the idea of degree of support. Now, these examples are very simplistic, and induction will get more complex than this. But keep in mind that unlike deduction, where validity is an all or nothing thing, it's valid or it's not, in induction, everything is just a matter of stronger and weaker and a bunch of gray area in between. Think about this particular example. Alcohol has never been prohibited in the United States. Indeed, such a prohibition has rarely even been publicly discussed. So it is very unlikely that it will be prohibited here anytime soon. Now, if you take a moment to think about this particular argument, would you say that it is a strong argument or a weak argument? Now, if your inclination was to say that this must be a weak argument, and your reasoning for this is that the first claim there, alcohol has never been prohibited in the United States, is a false claim, remember that strength and weakness, just like validity, has nothing to do with the truth of the statements. These are considered hypothetically. Imagine it were true that alcohol had never been prohibited, and indeed, it was also true that prohibition was never seriously discussed in this country. That's actually a very good reason to think that we're not going to have prohibition anytime soon. Now, this argument fails not because of strength or weakness, but it fails because it has a false premise. This means that this argument is not cogent, but the fact that it's not cogent is not a good reason to think it isn't strong. So if you go a little further on in your book, you will find another chart, just like the first one we saw with deduction, that deals with induction. This chart is also incredibly valuable, and it shows every possible relationship that could exist between strength and weakness, as well as the truth claims of an argument. And just like with deduction, it turns out that it's pretty much anything goes. The connection between strength and truth claims is quite tenuous, and pretty much you can have whatever except the one instance that we saw with validity as well. You cannot have a strong argument where the premises are all true and the conclusion is probably false. In any other case, anything goes. So I can have an argument where everything's true, it might be strong, it might be weak. I can have an argument where everything in there is false premises and a false conclusion. That might be a strong argument, it might be weak. We cannot really form any judgment whatsoever about this based simply on the truth of our claims. With, again, the one exception that if my premises are all true and I get a false conclusion, we know that this cannot be strong if it's inductive, and it cannot be valid if it's deductive. The second consideration to take into account when we talk about strength of an argument is that what constitutes legitimate evidence in an inductive argument will really radically change based on the type of inductive argument that's given. What this means in a nutshell is that the sort of criteria we'd use for different types of inductive arguments is going to be very different in terms of how we'd sit down to determine the strength or weakness of an argument. That is, what counts as good evidence in an analogy will be very, very different than, let's say, a generalization. And what counts as good concrete evidence in a generalization or weak evidence in a generalization is something very different than an argument from authority. So what that means about induction is that you have to spend a lot of time focused on individual types of inductive arguments in order to figure out the process of proper evaluation. Now, again, it's worth noting that this class is not really dealing with induction. You do need to know the basic terms, and you do need to know how to distinguish a deductive argument from an inductive argument, but we will not actually spend any time evaluating inductive arguments. So that's an end to this particular video, as well as the module. If you have any questions about the material here or anywhere else in this particular class, feel free to contact me about it. Post questions on the discussion boards, send me an email or the like. Let me reiterate one final time that the material in this particular video is incredibly important. It turns out when we're finished here that everything we will do in this class has to do with the idea of validity. If you don't understand what validity is, what it means to say an argument is valid, what relationship it has to truth claims, and what relationship that has to soundness, a lot of what we'll do over the entire quarter won't make much sense. So I'd strongly encourage you to spend a little time here focused on this particular chapter, on this particular section of the chapter, and the various ideas that we talked about.